Hello students, greetings from KLS Nijlingappa and Independent PU College, Department of Physics. We welcome you all to this Bridge Course Session 2021-22. I am Pavitra, faculty in the Department of Physics. So I'll be discussing about a rainbow in today's session. If I ask you, have you seen a rainbow? Then you would say definitely yes. Then what is a rainbow? A rainbow is a multicolored arc made by the light striking the water droplets. Rainbows are also a result of refraction and reflection of light. You have already studied about refraction and reflection of light in your previous classes. Anyhow, I will be briefing about them in the upcoming slides. So, before getting into the concept of what exactly happens inside a water droplet, so that a rainbow is formed, let us know when and where does a rainbow form. Please observe the figure up here. A person is standing and the sun rays are coming from behind him. So always remember this point. Rainbows are always formed in the direction opposite to that of the sunlight. Rainbows can be observed whenever there are water drops in the air and the sunlight shining from behind the observer. Because of this, rainbows are usually seen in the western sky during the morning and eastern sky during the early evening. So if I ask you, can you touch a rainbow? You would say no. Yes, you cannot touch a rainbow because it's not a physical object, but rather it's a reflection, refraction and dispersion of sunlight inside the water droplets in the atmosphere. So we all know about spectrum, right? A band of colors is called as spectrum. The separation of visible light into its constituent colors is called as dispersion. Then why does this dispersion occurs? As we know, when visible light enters from one medium to another medium, it undergoes refraction. It might be from rarer medium to denser medium or denser medium to rarer medium. And because of this refraction, the white light, which is a constituent of 7 colors, it splits up. Okay, we know the constituent colors, right? It's Vibgyor, violet, indigo, blue, green, yellow, orange and red. So here, red light is the light which has longest wavelength, and that is ranging from 620 nanometer to 750 nanometer. So because of its longest wavelength, red light bends the least after getting refracted. Similarly, violet light has the shortest wavelength ranging from 380 to 450 nanometer, and because of its shortest wavelength, it bends the most. Then let us talk something about refraction. So the first figure that you people are seeing here is wherein the light ray, that is the incident light ray, is traveling from air medium to the glass medium. Air medium is nothing but the rarer medium and the glass medium is the denser medium. So the basic concept of refraction is, as the light enters from optically rarer medium to optically denser medium, it gets refracted and the ray of light will bend towards the normal. Here OA is the incident ray and OB is the refracted ray. I represents angle of incidence and R represents angle of refraction. And we will be measuring angle of incidence and angle of refraction with respect to the normal line. Then we have another diagram over here wherein the light ray is traveling from optically denser medium to optically rarer medium, that is from glass to air. OA represents the incident ray which is present in the denser medium and OB represents the refracted ray which is in the rarer medium. Again, we will be measuring the angle of incidence and angle of refraction with respect to the normal. And we know that as an incident ray travels from denser medium to rarer medium, it undergoes refraction again, but here the light ray will bend away from the normal. Yes. So if I ask you which one of the following figures is correct, is it A or B? We have two rainbows here. Which which one of the following figures is correct? Then most of you will say it's definitely the first picture which is correctly describing the sequential arrangement of colors in a rainbow. But if you ask me, then my answer would be both A and B. Then you might wonder, is it possible to observe two different arrangement of colors in a rainbow? The answer is definitely yes. So I guess you got my point now. So let's understand the concept of rainbow formation in a better way. Basically, there are two types of rainbows. One is the primary rainbow and second one is the secondary rainbow. If the colors of the rainbow are arranged in the order of red, orange, yellow, green, blue, indigo and violet, that is in the reverse order of Vibgyor, we say that it's a primary rainbow. So this is the rainbow which you can see often in the nature. Coming to the second type, it's the secondary rainbow. In this type of rainbow, the colors are arranged in the format of Vibgyor, that is violet, indigo, blue, green, yellow, orange and red. So if you observe this kind of rainbow, then definitely that is secondary rainbow. Now, I'm going to show you some three figures over here. So what can you observe from these three figures? The first figure talks about the regular refraction, wherein the light ray is traveling from water medium to air medium, that is optically denser medium to optically rarer medium. As we know, there is a partial reflection that even takes place when light ray travels from one medium to another medium. So here, as light ray travels from water to air medium, what happens? It undergoes refraction and the refracted ray will bend away from the normal. Yes, coming into the second picture. Now, the angle of incidence here is mentioned with the term C, right? Okay, compared to the first figure, we have increased the angle of incidence in the second figure. That means, if we are increasing the angle of incidence through certain degrees, the angle of refraction in the rarer medium becomes equal to 90 degree. That means the refracted ray will graze the surface of air and water. Okay, this angle of incidence itself we call it as critical angle. And looking into the third picture, if we still on increasing the angle of incidence, which means the angle of incidence is greater than the critical angle, what happens? If it is equal to critical angle, then the angle of refraction will be equal to 90 degree. What happens if you are increasing above critical angle? Then the refracted ray will completely get reflected back into the same medium, which means into the denser medium itself. So this phenomena is called as total internal reflection. These three figures talks about the different phenomena that are happening for different angle of incidences. Total internal reflection is one important concept that is required to understand the internal phenomena of a water droplet. Next, let us study about primary rainbow in detail. So now, let us consider two water drops and sun rays are entering the raindrop, which means the rays are entering from optically rarer to optically denser medium. Now what should happen? Some amount of light, because of weak reflection, it will reflect back, wherein the most amount of light gets refracted into the water droplet from its first phase. Then after getting refracted, what happens? The light is going to split into its constituent colors. If you can see, the sunlight, as soon as it enters water drop, it gets splits into red and blue. Why am I showing red and blue? Because all other colors are coming within that range. It means in between red and violet. Now the refracted light in the denser medium, that is inside a water droplet, it is going to strike the second surface of the water droplet and it is going to reflect back. Why is this reflection happening at the second phase? Because of total internal reflection, which means the refracted ray here it is going to be incidented on the second phase at an angle greater than the critical angle. Okay, at an angle greater than the critical angle, such that the ray will get total internally reflected. And this total internally reflected light ray will now strike the inner surface of the water droplet and gets refracted outwards. Now the ray of light is traveling from denser medium to rarer medium, hence it gets refracted into the rarer medium. As you can see, we have considered two water droplets over here. For an observer who is standing at point O, the violet light from the drop 1 goes above, right? The violet light from the drop 1, it goes above the point of observation, whereas the red light from the point 2 or droplet 2, it goes below the point of observation. What happens exactly is the red light from the drop 1 and the blue light or the violet light from the drop 2 are only reaching the observer's eye. So the observer will be able to see red light in the top and violet light at the bottom. Hence, in a primary rainbow, the colors are arranged in the order red, orange, yellow, green, blue, indigo and violet. So this is about primary rainbow. Now let us study about secondary rainbow. So this diagram shows about how a secondary rainbow is formed. Now let us see the phenomena. The sunlight is entering the droplet, that is, it is traveling from optically rarer medium to denser medium. Some of this light will, of course, due to weaker reflection, it gets reflected back into the same medium. Rest of the light will get refracted into the water droplet from its first phase. Now the light is getting splitted up into its constituent colors. So you can see red and violet light over here. All other colors comes within this range. Now the refracted light in the denser medium, that is inside the water droplet, strikes the second surface and undergoes total internal reflection over here. And then after getting totally internally reflected, the light ray will travel inside the water droplet and strikes another side of the water droplet. Now again at the second phase, what happens? It undergoes total internal reflection again. And therefore, after getting total internally reflected for the second time, the light ray is now traveling in the denser medium itself. That is, the light ray is still in the water droplet and then it strikes the first surface. Therefore, the constituent colors are being splitted up. So, if you just consider two water droplets over here, for an observer who is standing at point O, the red light from the drop 1 goes above the point of focus, whereas the violet light from drop 2 goes below the point of observation, wherein the blue light from the droplet number 1 and the red light from the droplet number 2 only reaches the eyes of an observer. Hence, he can observe violet light to be on the top and red light to be at the bottom, wherein in the secondary rainbow the colors are arranged in the order violet, indigo, blue, yellow, orange and red. So this is how you can differentiate between whether the rainbow that is formed is primary rainbow or a secondary rainbow. Okay. Primary rainbow looks like this. The red color will be at the top and the violet color will be at the bottom. The secondary rainbow looks like this. The violet color will be at the top and the red color will be at the bottom. So here you can observe double rainbow over here. So you have a primary rainbow on the other side and the secondary rainbow which is little light in color, which is not clearly visible. So thank you so much for watching the video.